So as I said, we will load our data by the third method that we discussed yesterday. What was that? It was about saving our project. Okay, so first you have to save your project. Okay, so as I have already saved my project, it is showing me project home, and you know how to save your project. So how you can do that? Go to save as, okay, and it will uh, browse you through your to the folder of your interest or wherever you want to save your project, and then give it a name, okay, and click on save. Okay, so once you are done, it will create a project home for your data. Next, so I have provided you this Etna underscore volcano TIFF. Okay, so we will use this. So we will use this drag and drop option. Okay, so it is asking me about the EPSG. So I'll go with WGS 84, and today I'll show you how you can know the UTM zone of your area of interest. Okay, I'll click on OK. See, we were working in this region because this Etna volcano region. Okay, so let me just deactivate this first. Okay, now this is deactivated. Okay, so with this gray band image, are you able to infer anything? No. Okay, so this is just a legend, continuous legend, which is showing us values from -10 to 3313. You can right click here, okay, and go to properties to check what type of data it is, right? It has all the information, right? So this is your maximum elevation in the region. This is your minimum elevation in the region. So there are different information on CRS, okay? So you can go through it if you are interested, okay? We just close it for now. Yeah. So looking into this map, we are not able to visualize anything. We have to make a we always have to make a map so that not only us but other people to whom we are sharing the details should be able to understand the information at once. Okay, so that's what we are going to do today. Okay, so this is a single gray band raster. Okay, and here we are not able to understand the terrain characteristics like slope, elevation difference, topography, etc. So topography is the physical appearance of any feature on the landscape. Okay, so Mount Etna, as I talked about Mount Etna, so Mount Etna is an active stratovolcano, okay, located on the eastern coast of Sicily, Italy. Let's see its location. For that, I will download this Google satellite data. Okay. If I zoom out a little bit, then you can see this heel-shaped country. This heel-shaped country is this heel-shape is characteristic of Italy. Okay. If you don't know where Italy is, just find this heel-shaped country. So this is your Italy, and here is your volcano. Okay, Sicily volcano. If you close it, see, this is how this looks in the Google satellite. Okay, so now let's try to color this. Let's try to give this some color, and let's make it visually attractive and informative as well. Okay, so for that, what you have to do, click on the layer that you want to color with, or you want to decorate, right? So after that, in your layers panel, go to this brush like icon, which is when you hover over it, it shows open the layer styling panel. Okay, so click here. I hope you all are able to find out this icon. Okay, so once you click, as soon as you click on this, you will get one more panel, okay, on the right side of the window. So let's adjust this. Right. Okay, so here you can see that it is saying that this has only single band gray color. Okay, now we will try to give it some pseudo color. Okay, because this data is not in your red, green, and blue band, so we have to provide it some pseudo colors. Okay, and that will be your single band. Right? See, I think this looks better now. Okay, you are able to see at least some topmost value is 3313. Okay, maybe somewhere here, and this is your -10, maybe somewhere near the sea. Okay, near the ocean. Okay, next step. Suppose I don't like this color. Okay, okay, then I can change these colors from the color ramp. Okay, you see this color ramp option here. You can change the color ramp. You can make it a parula or spectral or anything. Okay, so this is the whole list of all color ramps present in QGIS. So this list is not limited to what you are seeing here. Okay, you get a bunch of other color ramps online, which is another advantage of using QGIS. Okay, so there is a community who is always developing different colors, different color combinations. Okay, and people are working on that. So you can add all those color ramps to your QGIS. Okay, maybe we are going to discuss that as well sometimes in our exercises. Okay, so you can use any of these color. Okay, for now I'll just leave it here. And next, let's add contour lines to it.
Yes, ma'am.
Yeah. Okay. Now let's add contours to our to the PEM that we have loaded. Okay. For that, just type on the locator bar contour. Okay. So everything related to contour will pop up on your screen. Okay. So we want contour polygons. So I'll add contour polygons. Double click on it. Okay. After that, you have to give it input layer. Okay, we are going to use Etna volcano TIFF file. Okay, and after that, you have to define the interval between your contour lines. Okay, contour lines interval. Let's say I'll go with 200 meters. Okay, 200 meters, and you don't want anything to be offset from 0. Okay, and attribute name for minimum elevation of contour polygon. It should be, if you can change this name, if you want it to be whatever default is, that's fine. Okay, this is for your maximum. This name will be shown in the attribute table. Okay, if you are working with 3D data, if you want your polygons to be represented in a 3D map, then you can click on this produce 3D vector. Okay, and let's leave everything as it is. And this GDAL, you see this GDAL, right? So whatever information we have given above, it has right. It is writing it in a console in a language that can translate our data into a processing. Okay. So GDAL is actually a translator library for raster and vector geospatial data format. So whatever processing we are doing the with the raster data and vector data, it is done by GDAL. Okay. So after this, you can click on run. See, everything is they have provided you all the processes, what algorithm, what is input, and you have created 3D, right, and field name you have given, right, and where your data will be saved. So your data is actually your temporary output. Okay, so we will learn how we can make it permanent. Okay, let me close this now, right? So this is your contours. So contours, they are increasing from bottom to the top. Okay, and we don't know which one is the bottommost contour. Okay, just looking at the contour, we cannot say that, because here you saw that there were some topography. So maybe these, sorry. So these, let me put my phone in silent. Yeah, okay. So these contours may be higher than these contours. Okay. Now we want to see our contours. Okay. Now we want to see the topography using the contour values. Okay. Again, what you will do? You will click on the contours. Okay. So next will be to again open, because your styling panel is already open, if it is not open on the right hand side, you will again click on the open the layer styling panel. Okay, and after that, here it is showing you single symbol. What does that mean? Single symbol means that this entire feature, right, entire feature will be filled with a single color. Okay, whatever single color you will give, it will be filled with that. Okay, so if you want to change the color of all these contour polygons, but you want to give a single color, in that case you will use single symbol, and you will click on the simple fill, and after that you can change the colors. Okay, see, in this way you can change the colors, or maybe you can select from here. Okay, select from here, right? And if you want to remove this line, right, line color, then you can change the stroke color from here. Okay, change the stroke color, you can make it transparent. Can you see the transparent button here? Option, okay, transparent. See, all the contour lines became invisible. Okay, all the lines became invisible, but here you can see, because why we are able to see this? Because of this color. Okay, okay, next is, let's try to categorize it. Okay, I'll again give it some color. Okay, now let's try to categorize it and see what are these different contour values. Okay, and for that you'll go to single symbol, click here and change it to graduated. Okay, I hope you all are able to find this option, graduated. Okay, see, everything disappeared. Why? Because for graduated we have to provide some value. Okay, on what basis we want to put the classification. Okay, use the classification. So it has given us elevation minimum value, it has given us elevation maximum value. Okay, after that you will come to this mode of classification. We will learn about all these terms. Okay, don't worry about it. You will come to this mode of classification, whether you want your intervals, value intervals, to be on equal count, like 0 to 680. The number of values in 0 to 680 will be equal to number of values in 680 and 1360. Okay, this is how it is classified. So next is your equal interval. Okay, so from 680 to so the interval between the lower value and the upper value will be same for all the classes. Okay, and here is your natural breaks. Natural breaks actually considers when there is break in the value. Okay, so suppose 0 to 200, it is a class where you have the maximum value, then there is a break from 200 to 800. Okay, there is a second class of values, right? So this is the breaks in the values that they are using to classify. Okay, similar, it goes like this. Okay, I'll go with this equal count. Okay, I'll go with this one. You can also change your number of classes here. Okay, so let's understand why we are using graduated styling. Okay, by the way, this data, your contour polygons, is your vector data. This data is generated in the vector format using your raster data. Okay, if you want to generate your vector data from raster data, you can do that as well in QGIS. Okay, right? So this is your vector data, right? So graduated vector styling, it applies one symbol per range. Okay, one symbol per range, okay, of the numeric attribute values. And this vector style is best when you want different symbols, that is based on a range of numeric attribute values. Okay, so we have a range of numeric attribute values here, such as when you are classifying the elevation values, your population count, or the literacy rate, anything, any classification you want to, whenever you want to classify your numerical values, you go with the graduated classification. Okay, and as I said, there are number of methods of classifying your numeric data: equal count, interval, fixed interval, logarithmic scale. Okay, so them will be, number of values will be same. Okay, and and natural breaks, as I said, this algorithm finds the natural groupings. Okay, so you get the natural groupings of the data. See, can you see the diagram as well of this here? See, it has some natural groupings of data. Okay, and the resulting classes using natural breaks will have the least variance. I mean, the variability between these two classes will be very less. Okay, suppose some values are between 0 to 10 and another group of values start from 15. Okay, so it is unnecessary to include 15 in our 0 to 10 classification, or increase the classification from 0 to 15. If we have a maximum number of values from 0 to 10, then of course that is more feasible. Okay, okay, so these are other different type of your classification. Okay, mode of classification. You can experiment with them, whatever you like, you can go with them. I'll go with this equal count. You can also increase or decrease the number of classes. Okay, I'll go with 5 classes here. And next, let's change our color ramp. Okay, so I'll go with spectrum. I like this one the best. Okay, right. So now, can you see some sort of 3D effects? Right. So this is your top and this is your base. Now, what if we want to bring this red at the top and this blue at the base? How we can do that? For that, we just simply have to invert our color ramp. Okay, go to this down arrow, half arrow, and click on this invert color ramp. Okay, see, this is how you can do that. Okay, I hope everything is clear. Do you want me to repeat anything till here?
No, ma'am.
Okay, perfect. So, yeah, so let's proceed. Now, let's give it a more 3D effect. Let's learn how we can do that. Okay, so for that, what you have to do, you will go to symbol. Okay, click on this symbol. Okay, and after that, click on the simple fill. Okay, simple fill. So when you are when you are not classifying your values, this color will be allotted to all these polygons. Okay, so after that, if you want to give some 3D effect, what you can do, go to simple fill. After that, you click on this draw effect button. So click here, draw effect button. Okay, after that, click on this star like icon. Alright, so you will get this window here, and so the effect is based on the source. Okay, now in addition to source, we want to use drop shadow. Okay, drop shadow. Let's see, you got your stair like appearance of the data. Okay, I hope this is more convincing. Okay, so you got your drop shadow. So if you want to change the parameters for dropping shadow, you can change the blur radius. See, here you are getting this shadow effect is blurring out. Okay, you can change the value of it. Let's say I want to go with 2. Okay, so there will be slight change in the blur radius. All right, next how okay, I hope this is clear. Okay, now we are done with decorating our contours. I hope this is clear that now you can see that this elevation level is quite similar to the elevation level we are seeing here, and this is the bottommost elevation layer. So this is like a stairs you are climbing up. Okay, so do you all know what contours are? Okay, let's discuss. So contour lines are basically, they connect points of equal elevation, okay, above sea level, and meaning that if you physically follow a particular contour line, suppose this contour line, that means that you are walking at the same elevation level, okay, or height of the land. Right, contour lines show elevation and shape of the terrain. Okay, say that okay, this is a hill, okay, because your contours are sorry, getting the area is getting smaller at the top. Okay, here the area covered by this contour is much larger than the area covered by the top contour. Each contour, and you can also identify the depressions, right? Hills and some thin mountain ridges, etc. Depending upon the area you are working. And each contour line on a contour map represents a specific elevation. Okay, specific elevation. If you want, you can also put their values. Okay, elevation values, right? And the spacing between them. Can you see the spaces between them? Right? So this is the spacing, right? This is the spacing. So the spacing between them represents the steepness, okay? Steepness of the terrain. So if I ask you, like, whether this is steeper or this is steeper, what would be your answer? The first one or the second one? This is the first one and this is the second one. Which you think is the steeper?
Second one.
Yes, exactly. Okay, second one. Why? Because here the elevation is changing at a shorter distance as compared to this one. Okay, here you have more distance, more distance between the contours, and elevation is changing gradually as compared to this one. So this one is your steeper. Okay. So this is what we call a topographic map, a map in which you find the contour lines is called your topographic map because it tells you about the shape of the terrain. Okay, even from the zoom out view, you can see that this looks steeper, right? This looks steeper, right? So this information can be helpful when you are selecting a hiking route. Okay, and in addition, your engineers, miners, geologists, they also use such maps. And farmers, farmers also depend upon the land they cultivate, right? And they should be aware of the natural structure of the landforms. Okay, and for example, the farmers like who cultivate using plantation farming must know the altitude and the direction of the slope on which their plantation depends upon. Okay, they should also know the direction of sunlight, from east to west, right? And heavy rains, because if they plant something on the steeper slope, what will happen during the heavy rains? There will be more soil erosion, okay, and which won't be good for their cultivation, for their crop cultivation. Okay, I hope the concept and the usefulness, both the things are clear in everybody's mind. Okay. Okay, so let's talk a little bit about the study area. So this Mount Etna actually is an active stratovolcano. Okay, stratovolcano is a volcano in which you have a layer of pyroclastic material and a layer of lava. Okay, and it is located on the, as I said, eastern coast of Italy. Okay, Sicily, Italy. So it has an elevation of 30 to 100 meters. So here it is 3313. So it is also taking a little bit of this elevation. Okay, and this is the highest active volcano in Europe. Okay, so most of the surface of Mount Etna, if we see in the Google satellite, okay, so this is your volcano. It is covered by this historic lava flows. Okay, these are all lava flows. Of course, this will be the recent one. If you go to the bottom part, you will find the older lava flows. Okay, and actually this is as old as 3 lakh years. Okay, 300,000 years. And scientists believe that it started as a submarine volcano because you see its location. This is something around the, like, this is the sea is enclosing it. Okay, so is believed to be started as a submarine volcano and that gradually grew to stand above the sea level. Okay, and upon the layer of the solidified lava. his geology and the usefulness and the contour presentation, everything is clear with all of you. Okay, so now let's add a base layer to it. Okay, let's learn how we can enhance it more. Okay, for that, what I will do, I'll go to the strato Etna volcano layer. Okay, and I will change this to a hill shape. Okay, so again, you will go to this layer styling panel. Okay, make sure you change your layer here as well. Okay, in the layer styling panel, in the first option. Okay, after that, we selected pseudo color layer first, and after that, you go to this hill sheet. Okay, hill shade. So how does it look like? See, this is the hill shade of your volcano. Okay, so see what now this is the top. You can, I think this is not quite good, but you can have an idea. Okay, right. So this is how your hill shade of volcano of this volcano looks like. After that, let's make it little bit brighter if we can make it. We will discuss about this altitude and azimuth, okay, in our upcoming lecture, so don't worry about it. Actually, altitude is the height or the angular height of the light source, okay. If you can see here, this is around 45 degrees, okay. So this is the vertical angle of the light source from the ground surface, okay, from the horizon actually, right? And your azimuth is the angle from north, from of the object. Suppose your object is here, then it is the angle of the angle from the north. You turn clockwise and you measure the angle of the object, okay. So this is your azimuth. If I rotate this, you can see our value of azimuth is changing, okay, right? Okay, let me keep it the default value 315. Okay, now let's change it, change the brightness. Let me increase some brightness so that it is more visible. Okay, so this is how you can just type the number, okay. Otherwise you can also use this to increase the brightness. Okay, now let's decrease. Saturation is related to colors, okay, so we are not going to use that now. Let me decrease the contrast. Okay, we are going to use this layer just as a base map, so don't worry about its appearance. Okay, and after that I'll click on the contour layer. Okay, see, your bottom layer and your top layer, your bottom layer is not visible, okay. Then what is the benefit of making it hill shape? I'll show you now. Okay, now let's go to contour layer again. So whichever layer you want to edit, okay, you have to click on that as well here, and you have to make sure that that particular layer is selected here as well, okay. So now what you will do when you are now when you want to see the bottom layer, or you want to see the effect of the bottom layer on the top layer of your raster, what you will do, you will go to this layer rendering, okay, click here, and here you will find this blending mode. Okay, blending is done, always done between two things. Okay, blending is done with two things because now we have two layers, we can blend them. So multiply is the option in which if you blend, then the colors that you are using on your legend, okay, or the colors that is represented, truly represented on your map, will be will remain as it is. Okay, it won't change. But with other blending modes, it will change. Okay, so always go with multiply. Okay, see, can you see this topography, this what you call it, texture? Okay, so can you see the texture of the bottommost layer? Now we have blended these two layers. Okay, now if you want to change the blending of this layer of the lines, then you will also, you can do that as well. Okay, I'll keep it light. See, I hope this looks better now. Now you can better understand the topography of the region, how the topography is changing. Okay, I hope this is clear, right? Next, let's switch the Google satellite. Okay, now if you want, you can again adjust the brightness. Okay, so whenever you want to, again I will insist that whenever you want to edit some layer, you have to click on the layers panel and make sure that this particular layer is selected here as well. Okay, so you can adjust the contrast, you can decrease or increase. See now, because now you have blended the bottom and the top layer, so now you can adjust the brightness for both of them. Okay, see, you can increase or decrease the contrast, right? I'll go with maybe 25, sorry, minus 25, sorry, minus 25. Okay, okay, and you can increase the brightness if you want, right? But with increasing brightness, we are not able to see the background texture, so we can leave it as it is. Okay, okay. Next is, what if you don't want to put this this hill shade map. We have another map which gives us the similar effect, that is ISRI shaded relief map. Okay, ISRI shaded relief map. So you can add that as well. Okay, let me close this. Right? See, you can also have the, now again you can see the effect of the bottom layer. Right? I hope you all are able to follow me till here. Okay, is that clear? Do you want me to repeat any step? Okay, so this is your final map. Okay, yes. Now, because our contour layer is a temporary layer, okay, temporary layer. Now we have to, any temporary layer, we have to make it permanent before we close it. Okay, before we close our project. So how you can do that? Again, right click on it, go to export, click on save feature as. Okay, you can use any of these formats. You can also go with KML. Okay, let me go with KML this time. Okay, and we will see how does it look in the Google Earth. Right, let's give it some name, contours at night. Okay, I'll go with day 3. Yeah, okay, and let's keep it okay, undefined SRS, and we have changed it CRS here. Okay, and geometry type, this is your polygons. Okay, click on OK. Cancel. I don't want to add layers here. Now let's see how does this looks on Google Earth, because as I said yesterday, your your sorry, this KML file, you can open it in, or you can load it on Google Earth. Okay, now let me open the Google Earth. Okay, for in Google Earth, how you open your file, you go to file, click on open. Okay, and let me go to the folder where I saved it. Okay, see, this is your contours underscore retina. Click on open and it will take you to that particular place. Okay, I hope you are with me, you are following these steps. Okay, exactly, we are at the same place. Alright, let me close this now. If you want, you can save on the Google Earth as well. I'll discard it for now. Okay, so this is our final map. Okay, now let's answer one question based on the map that we used, that we created. Okay, so based on what you understood about contours and topographic map, okay, the steepness and whatever, like, can you suggest that from which side of the volcano, north, east, south or west, right, a person should not hike, okay, not hike or climb if he or she wants to get to the top of this crater, okay, the top of this volcano, okay, for collecting, suppose the person had the task to go and collect the volcanic samples, okay, so which direction it should not opt for, okay, and you look into the final map and answer whether that direction should be from